right, so today we're going to go on to one of the extra topics at the end, graphical user interfaces and event-based programming, or event-based programming. It won't have anything to do with your final or the project or anything. This is one of those extra topics, just like databases that we'll cover on Thursday and maybe a little bit next week, depending on how much review we want to do. But databases, you'll get a whole bunch more databases in computer science too, and we actually design databases and cover SQL, the SQL programming language, structured query language, basically. All right, so it's not going to take long to cover graphical user interface and event-based programming, because I don't want to get it bogged down in the details of how to go about doing it in any particular framework. Because every single framework is basically the same 3 steps. You need a way to create what are called widgets. And what are widgets? Well, buttons, text boxes, labels, etc. You need a way to put those widgets into a layout, into a window, right? And once you've got that, then you need to add functionality. What happens when you click this button? And so those 3 same basic steps are everywhere in any language, in any framework for creating a graphical user interface. What I want to focus on instead are the principles behind graphical user interfaces. Up till now, you've been doing sequential programming, command line interface stuff, which is actually the vast majority of software, right? So why aren't we focusing on graphical user interfaces when you have this impression that every computer has a graphical user interface because it sits there in front of a person and that person interacts with it either with a mouse or on their phone or something like that. That's we get a warped sense of what software is for by only seeing that front consumer-facing kind of graphical user interface kind of stuff. The vast majority of software is not written for humans. It's written to it's either glue code, where you've got 2 pieces of software that need to speak to each other, or it's for automation. That's the whole reason we develop programs to begin with, to take humans out of the equation. So you do get kind of this warped sense that it's all about graphical user interfaces and programs like that, when that's only the very small tip of the iceberg. And down below here in the rest of the ocean, that's where the rest of the real programming happens, right? Most modern HCI, that's human-computer interaction, is done through graphical user interfaces, though, of course. And that's just because that's how most consumers wish to interact with their devices. You're not going to get grandma writing a script to execute a bunch of stuff. You're not going to get somebody to write a C program or a Java program to automate a process. They're going to want to click a bunch of buttons, right? And you either have a choice of thin clients or thick clients. Thin clients are basically just web browsers. And whatever web browser you choose, Firefox, Chrome, whatever, you can create a graphical user interface on that thin client that interacts with your server in the back end. That's why we call them thin clients, because they're not compiled for, they're not heavy programs like a thick client is. A thick client is something that you have programmed in C or C++ or Java or something like that, and you deploy it to a system. It requires somebody to download and install the actual software, right? It's the difference between my Spotify client that I had to install on my actual computer, that's the thick client, versus going to Spotify.com and playing it through my web browser. That would be a thin client version of that same application, right? Event-based programming is completely different from what you're used to with sequential-based programming. Sequential-based programming, you have command, A, B, C, D, right? You might have a loop that goes back and forth. You might have call a function or something like that. You might branch out if you've got an if-else condition, but it's basically sequential, back and the top to bottom, left to right. With event-based programming, because you have human interaction, you don't have a sequence of events, right? You have events that can happen out of sequence. If, for example, a user wants to do task A, B, and C, and these are all independent tasks, then they could do it in any order that they wanted. They could do B, C, and then A. They could be C, then A, and then B. They could be C, B, and then they forget about A entirely, right? Or it's redundant or something like that. What we have to do is not program for a sequence of instructions. We have to program for events. When somebody does this action over here, then we need to specify that this code over here gets executed, right? You rarely write the actual code that detects that a button was clicked or that renders a button. That's why you bring in the library to do it. That's why you bring in a graphical user interface, a GUI framework to do this for you. Again, instead of specifying what happens in the program, you specify what happens when an event occurs. Okay. There's graphical user interfaces go back at least almost 50 years now, right? All the way back to the early 70s with Xerox's Alto. They were the first desktop graphical user interface. It was more experimental. I don't think it ever even made it to market. I'm not sure about that. Certainly wasn't made popular. But through the 80s and throughout the 80s, then you started seeing more consumer electronics, more consumer computers. And that's because it made it easier to use. If you could point and click a document and just start typing, right? That appealed to a whole bunch more different people than computers up to that point, where you had to actually be a programmer to do anything on the computer, because there was these big giant mainframes where you had to actually program stuff. Of course, Apple and Microsoft blew that up in the 90s with more interfaces. Throughout the last 10, 15 years, we've had different mobile devices, right? So whereas you used to have just a simple point click, double click, those kind of events, now you have tap, double tap. What else can you do on your phone? Two finger gestures, right? What else? Pull down, right? Drag, swipe left, swipe right, right? All that kind of stuff. And then you also have different input devices even coming out today. You know, with not Kinect is kind of old, but VR and AR kind of stuff. Has anybody ever played with a HoloLens before? Microsoft HoloLens? No? Has anybody played with VR stuff before? Right? Oculus? That's certainly the cheapest. I would not recommend that you get one, though. One? All right. How about, I don't know, Vive? Oh, no? Okay. Join the UNL Game Developer Club at some point, and you can go and play the department's Vive. Actually, I just got a, what is it? What is Steam's version? Valve's version? Valve Index. There. I just had to say Valve Index. And that's got full hand articulations. So what can you do now? You can, click in 3 space, and it'll detect that kind of stuff. So as human-computer interaction develops and changes, you have different events and different types of interaction with an actual program, right? And it gets updated, gets updated yearly, if not more. Right? You've got a lot of different frameworks. The framework that I'm going to be demonstrating today in C is going to be GTK. There's also, of course, for C++, you've got GTK+, Qt, XW widgets, a whole bunch of other things. For Java, this is kind of a progression of development. AWT is what they started out with, Abstract Windowing Toolkit, or whatever it is. Then they built Swing on top of that to make it a little bit more programmer friendly. And then they built JavaFX on top of that to make it even more programmer friendly. Within the context of Java, of course, if you are doing something on an Android phone here, you've got an entire developer studio over here. Most of these are going to be programming environments where you actually program, and I'll show you the programs here in a moment. But otherwise, usually they have some add-on that allows you to not have to program the interface. Instead, you have a WYSIWYG. What you see is what you get kind of environment. Where you want to put a button here, okay, go ahead and drag and drop a button. Oh, okay, that's too far left. All right, then move it right, or move it left and move it up or down, right? It looks something like this. This is just a screenshot of Android Studio. And over here on the right, you've got your what you see is what you get kind of environment where you can drag and drop stuff over. And then when you actually do have to program what happens when somebody clicks a button over here or clicks an image or something, then you actually have a coding environment over here. It looks like an IDE, looks like Eclipse. That's because all IDEs look very, very similar. But you have a WYSIWYG environment over here. Remember, we are online, so if you have any questions, please go ahead and post to Piazza or to YouTube. Right? Anyway, if you're going to be on iOS, thankfully you don't have to do Objective-C anymore. You can do Swift. But most of these languages, frameworks, whatever, they're all going to have the same 3 basic steps. You need to create widgets you need to lay them out in an environment, and then you need to specify what happens when somebody interacts with those widgets, if they're interactive. With the graphical user interface system itself, there are a lot of components to it. For example, you have a windowing system. That handles low-level functionality, for example, pulling in input from a mouse. That they moved the mouse up 1 pixel, or they moved it down 1 pixel, or whatever, 1 unit, or whatever that is. That they clicked the button, that they mashed the keyboard, right? That's the windowing system. It also handles the graphics rendering. You don't want to have to program and reinvent the wheel and make sure that every single pixel is rendered exactly as specify exactly how it gets rendered, right? That's taken care of by the windowing system. Then you have on top of that, you have the windowing manager that handles the interaction of applications back and forth. You can have multiple applications open at the same time. The one in the foreground is the one that's giving your focus, right? And if you hover over something and click, how does it know that you're clicking on this one in the foreground versus this one in the background? That's the windowing manager's responsibility. And it's also its responsibility to inform all the other widgets of what happens when an event occurs. If somebody comes in and clicks a button, right, then it needs to tell your program, whoever the event handlers are, that this button was clicked. Go ahead and do your thing. Right? That signal is sent by the windowing manager. And then, of course, you have widgets. Widgets are simply generic GUI elements. It's just a generic name to give all these things. We've all heard the term widget before, right? Just in the real world, what is a widget? It's a thing. It's a generic name for a doohickey or a sprocket or whatever, right? It's a thing, right? They may be invisible or visible. They may be invisible and then you make them visible. They might be interactive or static. In other words, you can interact with them and you can, like a button is interactive, right? You can also have things that are not that are interactive, but in different ways. For example, if you hover over something and more information pops up, we call that what? Do you know what that widget is called? More information. So you hover over it, and then more information just pops up. A tooltip. Right? You've ever heard of that before? Anyway, they might be interactive or they might be static, and you don't interact with them. For example, text boxes, labels, or something like that. That's just static text. On the button itself, the button is interactive, but you want to put a label on the button to give the user some feedback, visual feedback on what's likely to happen when you click this button. Does it say save? Right? Okay, save. Does it have an icon on it? Right? Like, what's the universal icon for saving a file? Oh, we don't know? That floppy disk, right? Floppy disks no longer exist, but we still use it as a symbol for saving stuff. Sliders, if you want to move something back and forth to increase the volume, to decrease the volume, right? You've seen all these things before. You take them for granted because they've been developed by these graphical user interface frameworks. Even more complicated things like date or time selectors, right? When you need a date, of course you can go ahead and type in a date, but it tries to lead you to good behavior by popping up this calendar that you can go back and forth and select the actual date on it. Right? And I absolutely hate the ones, especially in Canvas, I think, that start the week on Monday, because then you always click the wrong day, thinking that this column right here is Sunday, and then it's not. It's actually Monday. Right? Most of the mistakes that you've ever seen in due dates is probably because of that. At least my mistakes. A window itself is a widget, right? You also have images, icons, etc., pop-ups, and even layouts. You need to lay out these widgets in a window. Well, how do you lay them out? Do you lay them out horizontally? Do you lay them out vertically? These are rows, these are columns. You can lay them out in a grid fashion, right? A 4x3 grid is what we're going to be looking at here shortly. So all of these things are widgets. You do not want to have to program these things. Instead, a proper framework will be giving you a way to create a label or create a window without you actually having to specify, oh, by the way, this pixel over here should be gray, right? And then do that for all the pixels. No, that would be terrible. That'd be you writing your own graphical user interface framework, right? And people have done that. In fact, that's where GTK came from. Has anybody ever used GIMP? So GNU's image manipulation program. It's a free alternative to Photoshop, right? The same guy wrote GTK, and when he was writing GIMP, the Photoshop clone, he was so frustrated with the frameworks that were out there that he said, all right, I'm going to put this on hold. I'm going to go create my own framework, GTK, and then I'm going to use it in my Photoshop kind of clone. And that's how it was born. Right? I forget his name, though. Anyway, event-based programming is, again, different than what you're used to because there are several different aspects to it. First of all, it's user-centric. Right? With a command line interface, right, they can only ever type. In fact, in the early programs, when we asked somebody, please enter in a number, right, we had no way of preventing them from just mashing the keyboard and saying hello, right? And then we would read in a 0 and then output the garbage results, right? There was no way to direct the user to good behavior and to dissuade them from bad behavior. But with event-based programming and graphical user interface programming, you can. It's user-centric in that there might be multiple ways of accomplishing the same thing. Let's go back to saving a file. How can you save files? Typically. There's a button right at the top, the floppy disk button at the top. Right? You can click that and it'll save the file. Is that the only way that you can ever save files? No. Control S for power users. Power users that don't want to move the mouse around and can immediately type and get things done a lot quicker, right? So it's a flexibility issue where you want to appeal to as many people as you can in different ways. Another way of doing it is going up to a menu, pull down, file, save, right? And that's yet another way of doing it. There might be multiple different sequences of events that lead to this same result, right? And that's user-centric. There may not be a sequential control flow at all, right? That they could go up to file, almost hit save and think, nah, I don't want to do that. I want to go ahead and go back and type a little bit and then go up and save, and then I'll save with the icon instead, right? It's not going to have a sequential control flow. Instead, it's going to be event-based. Good user experiences with a good UI, again, will guide a user to correct solutions and dissuade them from bad actions. For example, if I'm about to delete something important, what typically happens? I'm about to delete this very important file. A dialog pops up, right? And that says, what? Are you sure that you want to do this? If I were at the command line and I just said rm everything, rm r starting from the root, right? What is this about to do? Delete the entire hard drive. Of course, I don't have access to do that. I'm on the CSE server right now, and I'm not going to do that. But what's going to happen if I do that? Here, at the root right there. Is it going to ask me, are you absolutely sure you want to delete the entire hard drive? Nope. It's just going to do it for me. Right? You know, some ways, there are some ways that you can add that extra check. Are you absolutely sure you want to do this, right? But with a user interface, a dialog pops up and says, you have two options, right? OK and cancel. That's what's called a modal behavior. Now, when you've got this dialog up here, we have an immediate question that needs to be answered. What a good user interface will do is it'll block all other actions. In other words, you can't go up to file and save. You can't go back and start typing again in your word processor or whatever you're using. Instead, you have this question you have to answer first, yes or no. Only once you've done that and the dialog goes away, that pop-up goes away, then you can return to normal activity. It puts you into a particular mode where your actions are restricted, right? And that's also good user interface, good user experience, because it forces the user to focus on good behavior and dissuades them from bad behavior. I've also seen interfaces where they want to be absolutely sure. So a dialog will pop up and say, are you sure you want to delete this? Yes or no? Yes. Another dialog pops up and says, this cannot be undone. Are you absolutely sure that you want to do this? Yes. And then finally it kills it, right? It asks you 3 times, right? The action, are you absolutely sure? Are you sure? And then are you absolutely sure? So, you know, it's on you at that point if you've ignored all the warnings, right? But that's modal behavior and good user interface. Another aspect of it is asynchronicity. User interfaces should not freeze up or block other actions while it's working on something. And for that, I've got this demonstration right here. This is written in JavaScript. This is a basic web page right here. Anyway, I can interact with these things. I can have it say hello. It pops up a dialog here and say, okay, fine. Look, can I interact with that other button while that dialog is up? Nope. Right? Good user interface right there. Right? I can select an action, option A, and then option 0 is selected, another option 3 was selected, et cetera, et cetera. What I'm going to do is I'm going to initiate an asynchronous delay. Now, all this is doing is going out to the a server and saying, go ahead and do something for 5 seconds and then report back to me. And it says done. Right? It's not actually doing anything substantial. But it does invoke a non-blocking asynchronous display. It's doing this thing off into the background. While it's doing it, it doesn't prevent me from interacting with the rest of the page. Right? So that's good design. That's asynchronous design. Right? What if I have a busy delay, a synchronous delay here? Right? When I click this button, it looks like it's frozen. In fact, if I try to click this button over here, nothing happens. If I try to click this button over here, nothing happens. Until whatever it was doing is done. And then it comes back and says, okay, what happened while I was busy working on this thing over here? Oh, they clicked that button? Okay, here's your dialogue. Oh, they clicked that over there? Well, the dialogue popped up, so there's nothing there, right? Again, a busy delay means no matter how many times I click over here, and I am clicking, it's not going to work, right? Until it's done, and then I don't, there we go. All right, let's do a busy delay here, and then say hello, say hello, say hello. I'm going to pop up, all of these dialogues. I think it only does one, but come on. Is this a good user experience? No. Imagine if games worked like this, right? And somebody else's bad ping, somebody else's bad lag on the network froze up your game, right? Until you actually received, it was all synchronous, and so you actually had to receive an update from their game in order for you to continue, right? It would everything would grind to a halt. You don't want that generally. You want asynchronous delay. If I hit save and it takes 2-3 seconds to save the file because it's writing to disk and it's a very large file, it should not prevent me from continuing to work and say, click on that dialogue over there or continue typing or something like that, right? Asynchronicity is what you want with a graphical user interface here because, again, it is user-centric. Events are also, by their very nature, asynchronous. There may be thousands per second. For example, let me go ahead and, you see my cursor right here? Let me go ahead and move it over here. How many events was that? Just one? Every single pixel move is an event, right? I'm moving the mouse. What other kinds of events are there? Let me go ahead and go back to this, and let me go ahead and hover on this say hello. Right? Oh, here we go. Hover on it. Do you see what happened? Simply moving this in is an event. On enter is an event on this button. How can you tell? How can you tell that that happened? It gives you visual feedback, right? What happened? Oh, we don't see what's happening? Maybe it's too subtle. Yeah, it subtly changes color. And also, my cursor changes from this pointer into the finger, giving me visual feedback, visual cues that this is an interactive element. This is a button that you can probably press to say hello, right? This is also a button, right? When I move out of it, it changes color too. Right? Let me go ahead and click over here. Move in, move out, right? It changes color. When I go ahead and move in and click, it changes color yet again to give me visual feedback that you have successfully clicked this button. Now, if I move out and then release my button, or release my grip, right, was that a click event on that button? Did a dialog pop up? Nope. A click is moving in, clicking. You can move around all you want. You can even move out as long as before you release it, you come back into it, and then you release it, and that's a click event. So a click, even a simple single event like a click, can actually be a very, very complex sequence of events, or sequence of states, or sequence of modes. So by their very nature, they're asynchronous. You can click a widget. You can move the mouse in and out. You can hover on things. You can drag. You can drop. You can tap. You can double tap. You can swipe, right? You can two-finger rotation even works, right? In fact, on my keypad here, it would work if the application that I was using supported it. If I'm looking at an image, for example, on Mac here with a preview, I can go ahead and just turn it on my keypad, and it'll actually rotate the image for me, right? So the keyboard is also an input device, and you also have, key up, key down, key combinations, Alt-S or Alt-Control-Delete, right? Only the combination of all three of those things at the same time causes your Windows device to reboot, right? How do we specify what happens when each one of these events occurs? How do I specify that I'll save the file, but only if Control and then S is hit, rather than Control and then Z? Control Z is the universal what? Undo, right? What's the universal redo? Control Y. All right. What's some more computer, just general computer skills here. What is the universal copy? Control C. What is the universal paste? Control V. What is the better paste? Shift Control V. What does that do? That pastes plain. So if you are copying from a website and it's going to copy the formatting and everything else along with it, including if you're copying from a table. But if you just want to copy just the text, Shift Control V, and it'll only copy paste plain without any formatting whatsoever. Very, very helpful. Right? All right. So how do we do all this? How do we create widgets? How do we say that when this button is clicked, for example, go ahead and call that function over there? Those are all called callbacks. By the way, what am I doing? When this button is clicked, call that function over there. I am pointing to that function. So how do you think we do this in C? With a function pointer. Exactly. With Java, it's going to be event like interfaces and event handlers and stuff like that. But regardless of the framework, it's these three basic steps. Create a widget, specify the layout of a widget, all the widgets, and then register your events. Let's go ahead and take a look at the C version that I've got here. This is just a simple keypad application. Right. I'll go ahead and make it larger so that you can see this. It's got user access right here. How many widgets do you think are comprised of this thing? What do you think? Lots, dozens. In fact, you'll see that this is over 200 lines of code and at least 2-3 dozen widgets. What are the widgets? Well, the window itself is a widget. These three buttons up here are widgets. The label, CSE 155E keypad access, that's a widget. This is another widget. This is a widget, and all these buttons, of course, are widgets. But there are lots of other widgets that you don't see. The window is a widget, but how did I achieve this nice, clean layout? Right? I had to create other widgets. Here's the actual window. There we go. We had a label up here, which was a widget. But to achieve all that layout, I also had a main widget that you never even see. Right? It is just for containing other widgets. In particular, I had I believe this is going to be a horizontal box here, and another horizontal box here, and another horizontal box right here. Oh, that's good enough. And what did I use those boxes for? Well, I put that label inside that. I put this text box inside the second one. Right? You can see it. Let me go ahead and put it side by side so you can see all these things. Right? And then finally, in this larger text box right here, what else did I put? I put 3 more widgets, 3 layout widgets, in which I put, finally, all those buttons. So there's a lot going on here. Right? And this can be done a lot easier if you use some sort of a WYSIWYG graphical user interface IDE where, okay, I'll go ahead and drag this button over here and create a layout over here, right, et cetera, et cetera. And it's called, it's not scaffolding, what is it called? Wireframing, right? You're creating these wireframes so that you can collect all these widgets around, and then it takes care of all of it for you. Let's go ahead and let's go ahead and interact with this program now. So obviously it's a keypad access. So 5, 9, 8, 7. Access granted or not? Access denied. Oh, okay. 2, 2, 2, 5, 5, 5. Oops, too many 5s. Clear that out. So what does clear do? Cleared it out up here. Now modal design. Should I be, if this is a key card access, obviously I'm searching, I'm thinking that this is going to be a numerical passcode, right? Am I allowed to just mash the keyboard? You can hear from those donks that I'm not. Why? Because I've disabled keyboard input for this text box. I am forcing the user to interact correctly by only giving me these valid numbers. They can, of course, clear it out if they make a mistake, or they can go ahead and hit enter and have their access granted. 1, 2, 3, 4. Right. So that's a pretty good program. Let's go ahead and take a look at the code that actually created this program. Uh-oh, where is it? All right, fine. New window, and then where is it? Here it is. There we go. All right. So you see that we have about 200 lines of code here just for the simple application, the simple do-nothing application. Let's go ahead and to start from the top here. I've got functions called clear input, enter password. Okay, that seems to have some connection to the actual application. Enter digit. Okay, but here's the main. What are all my widgets so far? I've got the window widget. I've got that main column widget that I outlined over here. Right? I've got column 1, 2, and 3 for those keypads. Right, the 4 by 3 grid that we see there. I've got horizontal boxes, top, mid, and keypad. So top, mid, the one that's going to hold the text box, and then the one that's going to hold the keypad. I create each one of these separately. And this is part 1 of that 3-step process. I need a way to create widgets. Well, GTK provides that for me. GTK VBox, new. Create a new, what's a VBox, do you think? Vertical box, right? Instead of HBox, which would be a horizontal box, right? And why do you create these boxes vertically or horizontally? When I add widgets to it, do I add it top to bottom, or do I add it left to right? Right? And that's the only difference between these two. Of course, you can also do grid layouts as well. How do I create a window? Well, I call GTK window new, right? How do I create? How do I add something? So how do I do the layouts here? I add to the window the main column. I add to the main column the first text box, the first box, the second box, and the third box. Right? I am building this thing through code, through each one of these lines of code, and then I put in the column 1, column 2, and column 3. I put that into the keypad. So you've got column 1, 2, and 3. That would only happen if you've got a horizontal box. Otherwise, it would add them vertically. So you'd have all 12 buttons aligned like this, right? Not a good layout there. So I show everything because by default they're all invisible. I create a label here. Initially, it's going to have user access, right? Where did that come in? Let me go ahead and kill this and rerun it. User access. That was the text that started out up here. User access, right? What else? I create a new input box. That's going to be this thing right here. But then I immediately disable it. I make it editable false so that somebody can't sit there and mash the keyboard. I then show it and I add it to my layout. Then I create a whole bunch of buttons. Why did I go in 7, 8, 9, 4, 5, 6, 1, 2, 3, 0, and then clear and then enter? Why do I go in that order? Because it's not 1, 2, 3. It is 7, 8, 9, 4, 5, 6, 1, 2, 3. Right? At least I add them in that order. I don't know if that's how I created them. Yeah, that is how I created them. Yep. The clear button is going to have a label, clear. So GTK button new with label. There are dozens of other GTK button new with different parameters and different names for those functions. You can create a button. You can also change it later on if you really want to. Why do all of these functions start with GTK underscore? So what?
So it's organized, so it's probably GTK.
So because that's the library, GTK, right? So it's named after the library, but why did they prepend everything with GTK? Remember, when you create a function called foo, there can only be one function with that name. So the way that they get around the lack of function overloading like you have in Java, where you have absolute value, absolute value, absolute value, you've got 3 different versions of that. The way that they get around that is by prepending everything with GTK so that it does not conflict with any other library. Now, you'd better not bring in another library with the exact same name, GTK, that prepends everything, because then you might have a conflict. But that's how they got around that idea. Okay. Then finally, step 3, you need to register your callbacks. What happens when the clear button is clicked? You should call this function over here. What happens when the enter button gets clicked? You call this function over here. Let's take a look at those functions really quick. Clear input, what does it do? It sets the text of the input box to the empty string. Clear enough. What happens when they hit the enter button, when they click the enter button? Right? Well, this enter password is called. What do? We get the text of the input box, and then we compare it to the password, which is hard-coded up here, 1234. And if they're the same, then we set the markup of the label to this thing over here, access granted with a bunch of weird stuff there. Otherwise, if the password does not match, we give it a different message, access denied. And in either case, we're going to call this other function that clears the input for us. What is all this stuff? What is that weird markup right there? Anybody recognize it? Not databases, but it's HTML, right? It's span. This is a span HTML tag, and inside I've provided some font color. That's actually foreground color is going to be green, and then the font weight is going to be bold, right? And this one is going to be red and bold, access denied. This is an opening tag, and that style will apply to everything between it and the closing tag of this thing over here. So GTK, and even we'll see here in a second the Java version of this. It supports basic formatting like using HTML and CSS. CSS stands for cascading style sheets. It's just a fancy, styling used in web programming in HTML. Okay. What about the buttons themselves? If key 1 is clicked, then we call this enter digit. That's what we do for all 10 of them, though. But we're also passing in some additional data to indicate, wait, which button was clicked? Otherwise, I would need 10 functions. The enter a 0 into the text box, append a 1 into the text box, append a 2 into the text box. What I did is I just had one function that did the same thing, but how do you know which digit to enter? That's how we're passing that in as extra information. And so let's take a look at enter digit here. What it does is it treats that data as a string. And then it gets the current data in the input box, creates a new string that's of size 1 more, right? The old size plus the key size plus 1. Why plus 1 again? If I'm creating a new string, the null terminating character. Again, don't forget those, right? And then I create a new string that's able to hold the new appended. So if it was 1, 2, 3 before, and then they click the button, now we're going to be able to have 1, 2, 3, 4 and the null terminating character. I copy that over. I concatenate the new key, and then I set the text. Up here, I got the text, get the text. Up here, I set the text of the input box to this new input, and then free that temporary string. Right? So I only needed one function in this case. After I've registered all those callbacks, I send it into what's called a pull loop. So if I didn't have this and I compiled, right, then it wouldn't do anything. It would create all these widgets, but then it would immediately terminate the program. Graphical user interfaces are different. Is the program terminated over here? What is the program doing right now? It's waiting, right? It's waiting for me to do something to interact with it, like press a button or move from one button to another button. Then it does something. It's event-based, right? It only does something when an event is triggered by the windowing system. Otherwise, it's just sitting there doing nothing. How do you sit there and do nothing in a computer program? While true, do nothing, do nothing, do nothing, right? While true, is there any input yet? Nope. The windowing manager hasn't told me that there's an event. Okay. Is there any event yet? Nope. Is there any event yet? Nope. 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 Until some event actually occurs, like a clicking of a button. So it's in this big giant pull loop, and the way that I get that kicked off is by calling GTK main, and it goes into this intentional infinite loop, listening for events. And only when, say, you click this X button up here, does the actual program terminate. I actually had to do that, specify that. On the destroy event, what do? You quit out of that GTK pull loop, that intentionally infinite loop there. Without this line, what would happen? And I'm not going to recompile it, but without that line, what would happen when I clicked the X button up here? Nothing, right? It would be like this, right? And it would just sit there and stay there forever. I would actually have to manually kill the program in order to get out of it. Right? Okay. Questions on that so far? All right, so if you are interested in doing Lab 14, you will have to do it in the lab. You will the C version. You'll have to do it in the lab. You'll have to do it on the SUSE Linux partition because the way that I'm doing this right now is through SSH tunneling, and it is being run and rendered on the server downstairs, but the actual graphics come through an X11 client here, and it's actually being rendered on my desktop. But otherwise, this was not compiled for Mac. This was compiled for the CSE server, and it's being run on the CSE server. It's just sending me a bunch of graphical data, and my clicking is sending it back to the server, and it's actually being run on the server. In order to do that, you'll have to use the computers downstairs because the setup for this is just way too much. What you can do, however, is the Java version. So here's Lab 14. If you want to play around with graphical user interface programs here. I'll go ahead and just kick this off. You don't need any special things at all. You can go ahead and run it right here. Why? Because Java is write once, run anywhere. You don't have to compile it for that specific system. You don't have to have a windowing manager for that specific system. It is all taken care of by Java. Same exact behavior here. 1, 2, 3, 4. Enter. Access granted. 2, 2, 2, 2. Enter. Denied. I can go ahead and clear it out as well. And of course, I can quit out of the program by hitting that X up there. How did this all work? Same exact 3 steps. You need a way to create widgets. You need a way to set their layout. And then you need to register callbacks in the event of what should happen when a button gets clicked. All right? And so I've got an input box here, JText field. What do you think that is? That's the text box. I've got a label. JLabel, what do you think that is? It's a label. Initially it says user access, right? And hey, what am I doing here? Again, the same HTML formatting if you want to get into HTML, HTML, CSS, web design, whatever, right? I set my input box to be editable, false. Right? I have a panel, and I can add things to that panel. I've got instead of having all these widgets over here, what I have instead is a grid layout. How big is that grid layout? 4 rows, 3 columns. It adds top to bottom, left to right. So that when I start adding the keys here, key 7, I add it. Key 8, 7, 8, 9, 6, 5, 4, 3, 2, 1. Am I right there? Or what would it look like again? Or 1, 2, 3. So there we go. 7, 8, 9, 4, 5, 6, 1, 2, 3, and then clear and then enter. It's gonna. I have to do them in that order because it's a grid layout, top to bottom, left to right. Right. With each one of these, I register an action listener, an event listener that is going to sit there and listen for a click event. That's the default here. And what does it do? Well, it sets the input to the old input and then appends an 8. This one appends a 9. This one appends a 4, etc., etc. What does the clear button do? Right? All it does is, or that's 0, sorry. Where is the clear button? There we go. There it is. All it does is set the text box to the empty string. What does the enter button do? Well, it gets the text and it asks whether or not that's equal to this hard-coded password up here, 1, 2, 3, 4. And if it is, oops, let's go back. And if it, no, okay. And if it is, if they are equal, then it sets to access granted with this nice green, bold red, or bold green markup. Otherwise, it'll say denied, red, bold. I get the entire thing working by invoking, by setting it into this, it's a thread, it runs on its own thread. And so I'm creating a new runnable. We're not going to get into multi-threaded programming in Java. We will maybe next semester as one of the extra topics. But otherwise, I name this to the keypad. I set the initial size to 250 pixels by 250 pixels. And I say, also, when they close, go ahead and kill out the entire program. But otherwise, I go ahead in main here. I create a runnable keypad. And I set it to be visible. If I didn't have that, what would it be? What would it look like? That's a good question. Let's run this again. Can you see it? Nope. It was running though. It ran for a little bit. Come on. See up here? You can see the keypad. It's just that the window is not visible. So quit keypad. There you go. And there might be someone running as well in the background. Nope. Okay, somehow it quit on its own for some reason. But anyway, let's go ahead and set that back to true so we can actually see it. And then, oh, it's over here. Right. Oh, is the other one over here? Nope. Okay, so there it is. Again, same basic steps. A way to create widgets, a way to set a layout, and a way to register events. That's all you need for any graphical user interface framework. Okay. Yeah, go ahead.
So is this the lab? Do we have to do the lab?
No, I've already granted. I mean, you could have done the Java version no matter what, even at home, because Swing is built into the the standard JDK. But in all fairness, since I gave the main section a free pass, I went ahead and gave the H section a free pass.
This is supposed to be the lab.
This was supposed to be tomorrow's lab, yeah. Or the C version, this would have been this not the keypad itself. The keypad is given to you as an example. You have to do you have to finish a calculator, and so we gave you the basic calculator. I forget what it looks like, but well, here, let's look at the Java version. So this calculator here, when I run this, I only have so 10, then 20. And then this is the output here. What happens when I add those? I get 30. What happens when I subtract them? It's negative 10. What happens when I multiply them? I should get 200. I can clear everything out. I can quit. The lab was very simple. The lab was add a division. Right? And then once you've added the division, take care of error handling. What should happen when you have a calculator and you go 10 divided by 0? Yeah, you print an error. You not print an error message anymore. Instead, a pop-up or something. They don't do that. Or on an actual calculator, what would actually happen? Like EX or something like that, or NaN, right? Lots of different things could happen. You need to be think about grandma. Right? Is grandma going to know what a NaN is? No. So you need to have good consumer feedback, right? Think of normal users, don't think of power users necessarily, just them. Don't think of other programmers as users. You need to think about people as users, and you need to give them as much guidance as possible. You need to have that modular programming where you prevent them from doing stupid things and you encourage them to do the right thing, right? So, any questions? No? I forgot to plug in my computer, so we're almost dead anyway. All right, then. I'll see you on Thursday when we start looking at databases. Again, it's just a high-level introduction. Computer Science 2 is where we do most of that stuff.